From the dawn of time, humans have gazed up at the stars. The night sky has always been a source of wonder and inspiration. We've wondered about those twinkling lights. Are we alone? What lies beyond our world? These questions have driven humanity to explore. The cosmos is a vast, uncharted territory, filled with wonders beyond our imagination. Galaxies, nebulae, black holes, and distant planets. Our ancestors told stories about the heavens. They saw patterns in the stars and wove tales of gods, heroes, and mythical creatures. They imagined constellations and heroes among the stars: Orion, the hunter; Cassiopeia, the queen. The desire to understand the universe led to the birth of astronomy and space exploration. From the first rockets to modern space stations, our journey to the stars has been marked by innovation and determination. Space is a harsh mistress. It's a challenging environment, unforgiving to human life. To survive and thrive in space, we need more than just courage and ingenuity. We need the right materials, the building blocks of our future among the stars. Just like on Earth, we need resources to build our homes, our vehicles, and our future. Imagine a toolbox. Not your ordinary toolbox filled with hammers and screwdrivers. Imagine a cosmic toolbox filled with the raw materials of the universe itself. This is what we need to explore and settle space. Our cosmic toolbox contains a fascinating array of metals, minerals, and other materials, each with unique properties that make them essential for our journey. Imagine the excitement of scientists and engineers as they discover new elements and compounds, each one a key to unlocking the mysteries of the cosmos. These materials are not just for study, they are the building blocks of our future in space. From constructing spacecraft to building habitats on distant planets, each material has a role to play. Imagine a thriving colony on Mars or a bustling city on a distant exoplanet, all made possible by the contents of our cosmic toolbox. Advanced technologies like 3D printing allow us to use these materials in innovative ways, creating everything from tools to entire structures right where we need them. The data we gather from these materials also helps us understand the universe better, leading to new discoveries and advancements in science and technology. Education and knowledge sharing are crucial. By teaching the next generation about these materials, we ensure that our journey into space continues to advance. Collaboration is key. Scientists, engineers, and visionaries from around the world must work together, sharing their expertise and ideas to make the most of our cosmic toolbox. As we look to the stars, our cosmic toolbox is our greatest asset, filled with the potential to transform our dreams of space exploration into reality. The universe is vast and full of possibilities. With our cosmic toolbox, we are ready to explore, discover, and settle new worlds, turning the unknown into the known. The journey is just beginning, and our cosmic toolbox is the key to unlocking the wonders of the universe. Think about building a house. You need bricks and mortar, wood and nails, glass for the windows, and tiles for the roof. Now imagine building a home not on Earth, but on the Moon or Mars. Where do you get the materials? The answer lies in utilizing the resources already present. Spacecraft represent the pinnacle of engineering. They must withstand extreme temperatures, micrometeoroid impacts, and the harsh radiation of space. The materials used in their construction are crucial to their success, and sourcing these materials from space opens up new possibilities. We've talked about iron and aluminum, workhorse metals both on Earth and in space, but to truly push the boundaries of space exploration, we need to look beyond the ordinary. We need materials that can withstand extreme temperatures, resist radiation, and offer unparalleled strength-to-weight ratios. Metals aren't the only players in the space materials game. Polymers and composites, often lighter and more versatile, are equally critical. Think of polymers as chains of molecules, like beads strung together. By changing the type and arrangement of these beads, scientists can create materials with a wide range of properties. We've explored the incredible properties of space-age materials, but the question remains: how do we access these resources on a large scale? The answer lies in asteroid mining, a concept that sounds like science fiction, but is rapidly becoming a reality. Imagine a future where spacecraft aren't built on Earth and launched at great cost, but instead constructed in space, using materials harvested from asteroids and the Moon. This vision, once the realm of science fiction, is becoming increasingly plausible thanks to the revolutionary technology of 3D printing. The universe beckons, filled with promise and the allure of the unknown. But reaching for the stars isn't a walk in the park. Space, for all its beauty, presents us with a gauntlet of challenges. It's a harsh, unforgiving environment, ready to test our ingenuity and resolve at every turn. Building in space is like constructing a skyscraper upside down while hanging from a bungee cord. The lack of gravity, while liberating in some ways, presents unique challenges to space construction. Every beam, every panel, every bolt needs to be carefully maneuvered and secured in a weightless environment. Energy, the lifeblood of any civilization, is even more critical in the unforgiving environment of space. We need reliable, sustainable power sources to run our spacecraft, power our habitats, and fuel our ambitions for exploring the cosmos. The challenges of space exploration may seem daunting, but within these challenges lie opportunities. Just as space pushes the boundaries of human ingenuity, it also drives innovation here on Earth. The quest for solutions to space-based problems often leads to breakthroughs with far-reaching applications. Imagine sending humans to build a lunar base or mine an asteroid. The risks are enormous, the costs astronomical. That's where robots come in, the tireless, expendable workforce of the future, capable of handling the most dangerous and demanding tasks in the harsh environment of space. Imagine waking up in a space habitat, sunlight streaming through a window, a gentle breeze rustling through a hydroponic garden. This isn't science fiction, it's the future of human habitation beyond Earth, and it requires innovative designs that provide both comfort and protection in the challenging environment of space. We are at a pivotal moment in human history. For millennia, we've looked to the stars with wonder and aspiration. Now we stand on the cusp of making those aspirations a reality. The materials, metals, and minerals we've discussed, these building blocks of the cosmos, hold the key to unlocking our future among the stars. The path to becoming a spacefaring civilization is not without its hurdles. The unforgiving nature of space, the vast distances involved, the technological complexities, these are challenges that will test our limits. Yet, it's precisely these challenges that will forge our resilience and drive our innovation. The future of humanity in space is a tapestry woven from scientific curiosity, technological innovation, and the enduring human spirit of exploration. Our dreams of venturing beyond our home planet are becoming more tangible than ever before. Astronauts undergo rigorous training, preparing for missions to the farthest corners of our solar system. These pioneers embody the spirit of adventure and discovery. Imagine a future where space tourism is commonplace, allowing people to experience the awe-inspiring overview effect, fostering a greater appreciation for our planet, floating in zero gravity, looking down at Earth, feeling a sense of unity with all of humanity. This experience can inspire a new generation of explorers and dreamers. Witnessing Earth from space is a humbling experience, reminding us of our planet's fragility and the importance of preserving it for future generations. The view from space reveals the intricate web of life that connects us all, highlighting the importance of working together to protect our planet. The future of humanity in space is about ensuring the survival and prosperity of our own.